Hello students, welcome back to the fifth video of this playlist. So in this video we will be solving question number 5 from January 2024 Mechanics 1 paper. So let's see what's the question number 5 from this paper is about. So right at first, in question number 5, you can see a figure 4 is given. Okay, so before starting question number 5, if I explain the concepts behind this question, it is basically from chapter number 8. That's the last chapter of your Mechanics 1 textbook, which is moments. The concepts, all the concepts you need here, it's basically related to moments. So let's get started with question number 5. So you can see a figure. So the introduction says a beam AB has mass 30 kg. Its mass is 30 kg and length is how much? 3 meter. It's 3 meter long beam. The beam rests on supports at C and D where AC equals 0.4. It is supported by at C and D where AC is 0.4 meter and DB is 0.4 meter. Okay, as shown in figure 4. Okay, we can see in the figure 4 a person of mass 55 kg stands on the beam between C and D. Between C and D. Okay, 55 kg. The person is modeled as a particle at the point P. Okay, the person is basically standing here. Okay, so if the person is standing here, its weight is how much? 55 g, right? 55 g. Okay, and since there are two supports at C and D, then definitely since the beam is in contact at these 2 points, so there will be what? Contact force, isn't it? Going perpendicular to the plane, to the beam. Okay, normal contact force at C, R of C and R of what? D. Okay, and then the person is modeled as a particle at the point C where Cp equals to x meters. Okay, Cp, where is Cp? C to P, this distance is what? X. Okay, C to P is x meter. The beam is modeled as a uniform rod resting in equilibrium in a horizontal position. That means the beam is resting in equilibrium. That means resultant force is what? 0. That's the introduction to this question number 5. Okay, so part A is asking to use the model and to show that the magnitude of the reaction of C is 686 minus 245 x Newton. Okay, so we need to find out the reaction at C. So here, look at, if you see the figure, you can see that the reaction at D, there are two reactions. One is reaction at C and the other one is reaction at D. But reaction at D is unknown. So since reaction at D is unknown and we need an expression for reaction at C, so that means we need to ignore the reaction at D. So in order to ignore reaction at D, if we consider the point D as the pivot, if we consider moments about D, it will help us to ignore the reaction at D. So we will do that. For part A, we will consider moments about what? Moments about D. Okay, so if you consider moments about D, what's the clockwise moment? Since the system is in equilibrium, so clockwise moment will be equal to the anti-clockwise moment. Okay, so clockwise moment will be provided by the reaction at C, right? Reaction at C will provide the clockwise moment since it is acting upward, and with respect to the pivot D, it will try to rotate the beam in the clockwise direction. So reaction at C times its perpendicular distance, right? Moments is the what? Force times the perpendicular distance. Yeah, so perpendicular distance is how much? It is point C, it is 0.4. the point D is basically 0.4 meter from the right hand side of the beam, right? So that means total length is 3 meter. So A perpendicular distance of point C from D would be times 3 minus 0.4 minus 0.4. Why minus 0.4 twice? 1 minus 1 0.4 is this one and the other one is that one. Okay, so this is clockwise, and what's the anti-clockwise? Anti-clockwise is basically 55g. Okay, so this is clockwise, it is equal to anti-clockwise is 55g times its perpendicular distance is how much? 3 minus 0.4 minus 0.4 minus x. Why? Let's have a look. 1 0.4 for this one, and the second one is for that one, and x is for point P, this one. That's it. And again, another one here, I didn't show you in the diagram. It is basically the weight of the beam, right? Okay, is the beam uniform? Yes, uniform rod, right? It's uniform. Since it is uniform, so that means the weight is acting at the middle, from the middle. Okay, so this is 30 g Newton. Okay, so this is anti-clockwise, isn't it? So that would be plus, this is plus 30g times what? Its perpendicular distance from the pivot, that is D. It is how much? 0. This is 1.5, right? 1.5 minus 0.4, this is nothing but 1.1 meter. Okay, now we need a value for the normal contact force at C, right? So let's do the manipulation. So reaction at C times what? It was 3 minus 0.8, that would give you 2.2, right? That would give you 2.2. This is equals to how much? It is equal to 55g times 2.2 minus x. Okay, 55g times 2.2 minus x. Okay, so 55g times 2.2 minus x. Yeah, so 55g times 2.2 minus x, and then plus what? Plus 30g times 1.1, right? 30g times 1.1. So 1.1 times 30 is how much? It is 33. So this is 33g. Okay, now we need the value for reaction at C. So that would give you how much? 55 times 2.2. What would be the value? Okay, what we need to show, let's have a look on it. That will that will let us understand better. 686 minus 245x. Okay, so if you multiply 55g, 55 times 9.8 times 2.2, this is basically 1185.8 minus, okay, if you if you multiply 55 with 9.8, you will get 539x. Okay, plus 33 times 9.8, that would give you 323.4 over what? 2.2. Okay, so our reaction at C, this is equals to how much? 1185.8 plus 323.4. It's 323.4. Let me write it clearly. 0.4. Okay, so that is 7. Okay, 1509.2 over 2.2, that would give you 686 exactly. 686 minus 539 over 2.2, this is basically 245 245x, and basically that's what the question in part A has asked to show, right? Okay, next is part B. For part B, they are asking They said here the magnitude of the reaction at C is 4 times the magnitude of the reaction at D. That means reaction at C, it is 4 times the reaction at what? D. Okay, we need to find out the value of X. Using this model, we need to find out the value for what? X. Okay, so in order to find out the value of X, what we can do? Okay, reaction at C, it's 4 times the reaction at D. Okay, so reaction at C, it is represented in terms of X in part A, right? We have showed it. So what we can do is that we can consider the forces vertically. Okay, because if you consider the forces vertically, then you are getting reaction at C, reaction at D, and the weight of the person, right? So that means all of the things are known here, and with only we will have X as the unknown variable. So then we can solve for X and get the value, right? So consider the forces vertically. We will for part B, we will consider the forces what? Vertically. So reaction at C plus reaction at D, this is equals to how much? This is equals to 55 G, right? The weight of the person plus the weight of the beam, this is 30 G. Okay, so reaction at C is known to us, and reaction at D is how much? 1/4 of reaction at C, right? Reaction at C, so since reaction at C is known to us, and we have represented it in terms of X in the previous question, so reaction at D can be represented as 1/4 reaction at C. Okay, so let's put it there. Reaction, okay, reaction at where? Okay, reaction at C plus 1/4 reaction at C, this is equals to 55 G plus 30 G, right? So this is 85 G. Okay, so that means 5/4 times reaction at C, this is 88 G. Now what we need the value for X, right? So X R of C, reaction at C, it can be represented as 686 minus 245 X. Okay, this is equals to how much? 88 times 4/5. This is how much? 352/5 times 9.8. Multiply the value for G, you will get 689.92. Okay, now from there make X the subject. If you make X the subject, what you will get? 245X goes to the right and take it to the left. So what you will get? Okay, why we are getting a negative value? 88 times 9.8 times 4/5. This is basically 689. Okay, let's have a look on it. Reaction at D is known, 55G, 30G. Okay, everything is fine there. 686 minus 245X. Okay, the reaction at C is 4 times the magnitude of the reaction at D. Okay, this is fine. Everything is fine there. 1/4 plus 1, that is 5/4 RC. This is 85G. That's fine. Oh, I wrote is 88. That's a mistake. Okay, this should be 85G. That's what the mistake is. Please correct it out. Okay, so 85 times 9.8 times 4/5, that would give you 666.4. Okay, 666.4. Now we need the value for X. So if you take it, you need to take it to the left and take 245X to the right. Okay, so 686 minus 666.4, this is 19.6, divide 245. This is basically 2/25. The value for X is 2/25. Done. They asked for the value of X, and we got the value of X is 2/25. That's it. So for part C, next is part C. the person steps off the beam and places a package of mass mkg at A. So the person is getting off from the beam and now he is placing a package of mass mkg at A. Where is A? Okay, the mass is coming here. Okay, this is mg. Now 55 G's disappeared. Okay, okay, okay. Next, they said the package is modeled as a particle at the point A. The beam is now on the point of tilting about C. Very important. It's on the point of tilting about C. Tilting about C means what? It's on the limiting equilibrium position. So you need to figure out like in which direction it is on the point of tilting. This is definitely the anti-clockwise way, because particle m has been placed on the anti-clockwise way, isn't it? So if the beam is on the point of tilting about C, then normal contact force at D, it will be 0 Newton. Why? Because since it is on the verge of rotating about C in the anti-clockwise way, in the anti-clockwise direction, that's why the contact between point D, the beam at point D, and the support is now the least. Okay, and that's why it is 0 Newton. Direction at D is 0 Newton. Okay, so part C asks to use the model and to find the value of m. This is very straightforward, very simple. Look, since the beam is on the verge of rotating about C in the anti-clockwise direction, so we will consider moment about C. Okay, we will consider moment about C to ignore its effect. Okay, so for part C we will consider what? Moments what? About C. If you consider moments about C, what's the clockwise moment? Clockwise moment is the weight of the beam, which is 30 G times its perpendicular distance is how much? Let's figure this out. 1.5 minus 0.4, that would give you 1.1. Okay, 1.1, and this is basically clockwise. So what's the anti-clockwise moment? This is nothing but the particle, that is m. So mg times 0.4, right? Its perpendicular distance is 0.4. So 0.4 times what? mg. Okay, now we need the value for m. Okay, so m would be how much? 1.1 times 30. G cancels out from both sides, so this is 33 over 0.4. So this is basically 82.5. Basically the value for m, it's 82.5. 82.5. Okay, did they ask for the mass or the value of m? Okay, they just asked the value of m, so we don't need to mention any units. Okay, so the value of m is nothing but 82.5, and that's what the part C has asked for. And that's the end of question number 5 from January 2024 State Mechanics 1 paper. That's it.